Just find the
Try turning it on and off.
laptop.
That's his job.
Put in a rice.
I don't know about rice. I don't think it got wet. Hope it didn't get wet. It's very expensive. Yeah. Very small grain, smallest grain.
No beans.
No bleach. Okay, so if you're on Zoom right now, I'm just going to share from my computer really quickly because we are not learning new material. Right? So what did we talk about on Wednesday? Anyone remember that far into the past? Yes, we're talking about how to code exercise 810, varying the step size. Right? So for today, I haven't moved it yet. Yeah, go ahead. So for today's class, it says boundary value, but Trinity's not going to do this. We're going to move all of this to the next week. And I think the homework should adjust. What we'll do here instead is we'll move that catching and debugging from week 9 up to today. And then we'll try and keep on track for the rest of it. So get actually in the same groups that you were in for Wednesday. Because we're going to work on that same piece of code. We're going to take that 810 example and we're going to do the adaptive step size, at least the algorithm as a group. Now, working on that after, for however long you want to, whether you turn that into your project or whatnot, that'll be up to you. Okay. Hey, look, looks like it's working. Let's do this. Let's use a different screen. Thank you, sir. Let's use this screen. And let's put this over here so everyone can see what I'm saying. Oh, where'd it go? Sure. Why not like share? Okay. So let's talk really briefly about why we are headed here. So if we go to, hopefully this loads. Damn it. I knew that was going to happen. Okay. We are getting close to this time period here. It says code proposal due. So you're wondering what that means? Oops, not that one. You're wondering what that means? Let's go to which course we're in. I think we're in 3300 spring. Seems reasonable. We'll go to modules. And here is the semester project. So now you will be able to read it. Okay. So the semester project is designed to explore your creativity and mastery of computational physics. You will design a problem and you will solve it. Some of you will come up with examples that don't use differential equations, and like 80% of those examples will be not usable for this class. There'll be fun problems, but they usually can be done analytically. What we're looking for here is a problem that can't be done analytically, that requires a computer to do it. So stuff can be hard, but not necessarily need a computer, right? So what I want you to do, and this is, I'm going to update the date here, but I want you to do is we're going to change this. You're going to submit the proposal to me by email. We're going to have a conversation about the scope, the topic, etc. It should be about 1.5 homeworks on a single topic. So think about the length of a homework, 2 or 3 problems, right? Should be about 4 problems, 5 problems length of work on the same topic, right? There's a lot of techniques that we'll be looking into. There's some stuff that you haven't seen yet, such as solutions for linear, nonlinear equations. This is your linear algebra section. There's stuff on random processes. So let's say you want to do the decay of atoms and you want to map how a mineral might look after 3 billion years, all of the different transitions that might occur. You might need a computer to keep track of all those, right? So that would be something you could do on a computer as long as you know how to generate random numbers. You can do things like Fourier transforms. So let's say you want to understand the power in some data that you're taking for your research. You can do that there too. You will need to start working on it sooner rather than later. If you wait till the very end, it will look bad and you will be stressed. Okay. There'll be a presentation. At the end of the semester, instead of an exam, you will present to the class your thing. So during finals hour, or however long it is, we'll just take up that entire period and everyone will do 7 to 10 minutes, including some time for questions. And you'll create slides and we'll talk about this more in context. It's really important for you to think about, I'm not trying to get you to reinvent the wheel. So if you have working RK4 code that applies, you can use it. If you have a package that helps you do your project, great, use it. But for everything that you do that uses a package or uses some other code, that will lengthen your contribution. So if you're just going to Frankenstein 5 homeworks into one, that's not acceptable. You need to create something new using the tools that you have. Does that make sense? The difference there? Okay. And we'll talk about this more in detail. There's a rubric for both. But the most important thing in the next couple of weeks is thinking about all of the different topics. So I added some here, stuff like quantum mechanics, classical orbits, what we're going to do today, Lagrangian dynamics. So that has to do with like, say, coupled springs or coupled oscillators, molecular dynamics. So let's say you want to simulate how sodium ions behave inside of a lattice, or solid state physics. Let's say you want to do sound distortion. We can talk about waves. We can do recursive maps. A lot of people love to do like, we have almost one per semester, someone who wants to do the Mandelbrot set. So if you've ever Googled that late night, after a night with your friends, it's really fun. It's recursive. It goes down and down and down and down. And it's these really beautiful patterns. You can learn how to make those on a computer, and you learn all about this thing called fractal geometry. You can do fluid dynamics for folks in my fluid dynamics class. It's a good way to tie these two topics together. You can do diffusion, say through materials, solid materials or fluids. You can do stellar structure, like the interior of a star can be modeled with a computer, and you can generate heat, etc. So if you have an idea, you can pitch it to me and I'll give you some feedback. I'll be like, yes, that's a good idea. No, that can be done analytically. No, that's way too hard for you to do, right? So you both don't want to pick a project that's too big or a project that's too small. And that's why we have feedback. And sometimes you'll get into the project and you'll be like starting to code it. And you're like, actually, I really hate this. And you can come to me and be like, hey, can I switch topics? Great, no worries. You can work with one another in building the project, but the whole thing needs to be your own. So if you and your buddy are both doing sound, modeled in an auditorium, you can't do the same problem. So one of you has to do something different. You could start potentially with the same type of code. Let's say you take, 8.12 and you both adapt that. That's fine, right? That's collaboration on something you've already done. But you can't say, oh, I took his code and I added these 6 lines here. That's my project, right? Does this process make sense? So you will be required to come up with a topic and pitch it to me before, when did I say? The 27th, the end of the month. Okay. Questions, comments, concerns? Anyone not? Yeah. No. This is your project. You work on this during project time. There'll be debug. There'll be debugging and catching up times. So of course, I build them in here. There's a little Slack everywhere in the semester. You can bring me your code during office hours. You can send me snippets and be like, hey, how do I get started here? We can workflow it together. You can say, hey, I have this idea for an algorithm and we can talk through your algorithm, right? Lots of communication is better. Okay. If you don't do the final project, what happens? F. You get a B? No, sir. No, sir. If you don't do the final presentation, what happens? No, well, it depends on how well you did in the rest of the class. If you have a really good reason, then I can understand it. But generally speaking, you should be expecting to do both. Project is more important than the presentation. Presentation can be weaseled out of, but I would rather you not try to. Okay? Okay.
We schedule a time to meet with you for the pitching idea.
Yeah, or just send me an email that sort of lays it out. You can do both. You can walk up to me and we can start chatting. Come to office hours, we can chat. I just need to sign off on it before you start. And if you want to switch, I also have to sign off on that. For what else was I gonna say? Shit. Oh, who has not done a check-in? Okay. Have you sent me an email or a Slack message? Okay. So send me a Slack message. Let's get those on schedule because you can't pass the class without 3 check-ins. 2 check-ins in a final. We don't have to have a final check-in. Okay. And then the next check-in is coming up soon too. So we'll probably do it right after spring break. So like the first week of April, maybe the second week of April. Okay. Okay, so go ahead and find your partner from Wednesday. We're going to work on 812. And we're going to talk about the algorithm for adaptive time steps. Okay. This week to Wednesday, or this Monday to Wednesday. Yeah. So you'll give your presentation on Wednesday. That's okay. For those who were here, how far did we get? Not far. Okay. So you're adapting the Lorentz equations, right? You use that as a basis. And then you add some intermediate steps to decouple the equations. Did you do that? No. Do we want to write on the board how we do the adaptive time step algorithm, or are we not there yet? Raise your hand if you're there. Raise your hand if you've simulated the object moving. Okay, all right, pause. Let me pause the recording. We're going to come back to this. All right.